Bismillahirrahmanirrahim. Assalamu alaikum dear students. I'm back with my new video on the third variant of paper 1 May-June 2024. So without wasting a single time, let's start with it. Here in this paper, the first question states X is an impure sample of group 2 metal carbonate MCO3. X contains 57% by mass of MCO3. The impurities in X do not react with hydrochloric acid. We are given the mass of X. It reacts with the excess of the hydrochloric acid, and then we are given the mole of the group 2 metal chloride. We have to identify which metal is present in the impure X, or in other words, which metal is present in the compound MCO3. So let's start with it. First of all, we are provided with the percentage value of the MCO3. So we can use this value to determine the mass of the MCO3 compound which is present in the impure sample. We are provided 7.4 gram, which means we need to calculate 57% of 7.4. So I will write 7.4 into 57%. So I will get the value as 4.218 gram. Now this is the mass of the MCO3 compound which is present in the impure X compound. After that, we also provided the information that this MCO3 is reacting with the hydrochloric acid, and only the MCO3 will react, impurities will not, which means I can construct an equation for the MCO3 with HCl. Okay, now I will write the equation MCO3 reacting with the hydrochloric acid HCl, and it produces, and I will get MCl2 plus H2O plus CO2. I have already balanced the chemical equation because we are provided we need 2 moles of the HCl. I will change its color. So 2 moles of HCl are required. Now after that, I can state some data which is provided to us. We are given 4.218 gram, which is basically the 57% of the actual compound, and then we were given 0.05 mole of the metal chloride. This M is 0.05 mole. Now using these two values, we can determine what is the mole of the compound MCO3, because we are given mole of MCl2, but we need to find the mole of the MCO3. So for this purpose, I am going to take a ratio between MCO3 and MCl2. Now we are given, according to stoichiometric ratio, we can see that there is 1 mole of MCO3, so I will write 1 here, and MCl2 is also 1 mole. Then I have to calculate the mole X of the MCO3, and I'm provided with 0.05 mole of the MCl2, which means the X value will also come out to be 0.05 mole. Now this is the value of the number of moles for the MCO3. And then, as we know that this mole has this formula M over Mr, and from this equation I can rewrite it to find relative molecular mass, because we need to identify the compound, we need to identify the metal present in M. So it will become small m over n. Now as we also know that we are considering the values of the MCO3, then in MCO3 there is CO3 present, so we can take out its value from it. Then I can write relative molecular mass of CO3, which is basically the carbonate ion. Its mass will come out to be 60, which you can compute. Now we have calculated its value. Now from here we can also calculate the value of the relative molecular mass of the metal M. How can we do this? We can find this by subtracting the value of the carbonate ion from the MCO3. MCO3 minus CO3 minus 2. We have found the value of the MR of carbonate ion, but we need to find the MR value of the compound MCO3. So for this purpose we can use this value of the 0.05. MR of the MCO3 is equivalent to 4.218 divided by 0.05. Now this will come out to be 84.36 gram per mole. Now that's the value for the MCO3, but we don't know which element is there in M. So I'm going back to this equation. I will put the values. MCO3 is 84.36 and carbonate ion is 60. The value comes out as 24.36. Now this 24.36 is the mass of the metal M. That's what we had determined here. So you can check the MR, which is basically here the AR, because we are considering one metal here, only one element, which means we can say one atom at this moment. So which means we can check this AR value from the periodic table, and this AR value matches with the element magnesium, and that's why the correct answer is A, magnesium. Now comes the question number 2. Which of these samples of gas contains the same number of atoms as 1 gram of hydrogen gas? Now here we are provided the masses of these compounds along with the MR values. We need to match these values of the relevant compounds with the mass of the with the value of the hydrogen gas. Over here we are given 1 gram of hydrogen gas. So from this value we can determine its moles. As we know, hydrogen gas means it is H2, and H2 has a mass of 2 gram. Now 1 gram of H2 means its mole will come out to be 0.5. These are the moles of the hydrogen gas. Okay, now we have computed the moles of the hydrogen gas. Now we need to compute the moles of all these compounds, and then we have to determine the number of atoms. So starting from the first compound, which is carbon dioxide, we are given 22 gram and its MR is 44, which means the number of moles will come out to be 22 divided by 44 is 0.5. Now here both the values of the moles are same, but in case of hydrogen gas the number of atoms are, as we know, 1 H2 contains 2 hydrogen atoms. It contains 2 hydrogen atoms. So the number of the atoms will be mole multiplied by number of atoms, so it will be 0.5 multiplied by 2, so 1 mole of hydrogen atoms. So in 1 gram of hydrogen gas there are 1 mole of the hydrogen atoms, whereas 0.5 mole belongs to the mole of the H2 molecules as a whole H2 molecule or H2 gas, hydrogen gas. However, we needed to calculate the moles of the atoms. So as we have calculated 1 mole of the hydrogen atoms, then now we have to calculate the moles of the atoms in carbon dioxide. 0.5 mole belongs to the moles of the carbon dioxide, whereas there are 3 atoms in a single molecule of CO2. So this 0.5 will be multiplied by 3 and the value will come out 1.5 mole. Now this 1.5 mole doesn't match with 1 mole of the hydrogen gas, so that's why A is not the right answer. Now let's move to the option number B, methane. We are given 8 gram, so 8 divided by 16 comes out 0.5. Now this 0.5 will now be multiplied by the number of atoms present in a single molecule, and we can see there are 5 atoms, so 5 multiplied by 0.5, so its value comes out to be 2.5 mole of the atoms in CH4. This value again doesn't match with the 1 mole, so it's not B. Then let's check D. D is 8 gram, so 8 divided by 48, value is 1/6, and then this 1/6 is a mole of ozone molecule. It will be multiplied by 3 atoms of the ozone. The answer comes out to be 0.5 mole, so that's not the right answer. Now C option, we are given 20 gram of neon and MR is also 20. We should recall that neon belongs to monoatomic molecule. Monoatomic molecule. All the noble gases are considered as monoatomic molecules, so that's it's on AR, so the mole comes out to be 1. Now since it is a monatomic molecule, it also contains 1 atom, so this 1 will be multiplied by 1 and the answer is still 1. And this is the mole of the atoms present in the neon molecule, and neon is made up of only 1 atom, so that is the value which matches with the 1 mole of the hydrogen gas. So I can say this 1 mole matches with this 1 mole of the hydrogen gas, and that's why the correct option becomes C. Now question number 3, what is the total number of protons, neutrons and electrons present in an ammonium ion with a relative formula mass of 21? Okay, so in this question we need to carefully check all the values. The ammonium molecule has a mass of 21, its MR value or relative formula mass value is 21. Then we are given some of the values in the columns. Okay, this ammonia has the formula NH4+, and its mass number or formula mass is 21. We know we have to calculate the proton, electron and neutron in this ammonium ion. Proton, electron and neutron. We know that in this ammonia molecule there is 1 nitrogen atom and there are 4 hydrogen atoms. The atomic number of nitrogen is 7 and the atomic number of hydrogen is 1, and there are 4 atoms, which mean there are 4 protons in the ammonia molecule. So in total the number of protons come out to be 11. Now comes the electron. The nitrogen has 7 electrons, so we will write 7. However, in case of hydrogen, there are 3 hydrogen atoms and 1 hydrogen ion. In total, there are 3 hydrogen atoms plus 1 hydrogen ion, and hydrogen ion doesn't have any electron, so the number of electrons will come out to be 3. So the addition is 10. And at the end, the number of neutrons. To calculate number of neutrons, we know it is the nucleon number minus the atomic number, and the nucleon number over here is 21, which is the same as the relative formula mass, and the atomic number of this ammonium ion is basically the same as the atomic number, the number of protons. It is the same as a number of protons, so 21 minus 11, the value is 10. So then, which means the number of neutrons is 10. So we have calculated the electron, proton and neutrons in the ammonium ion. Now we will check, we will put the ticks in the columns. Number of protons are 11, number of neutrons are 10, and the number of electrons are 10. So we can clearly see that the option A is the right one, which has 3 ticks. Now question number 4. This question is about the ionization energies of magnesium and neon. Okay, we are given the order of the ionization energies for magnesium versus neon, and we are given the electron removed. In my opinion, the students will face difficulty in the first column, and there is no problem in the second column, which is further divided into 2 sub columns, because we know the electronic configuration of magnesium and neon. We can simply tell which electron will be removed. Magnesium belongs to group to S block, so simply the electrons removed from the magnesium will be from S. It is in group number 2A, and 2A comes in S block. Neon, on the other hand, is present in group number 8, or we can say 0 group or 18 group, and its block is P. So the electron to be removed in case from the neon will be from P block, from the P subshell. Now the problem lies with the first column, that what should be the energy order for magnesium and neon. Now to find that, we need to check the periodic table. This is the periodic table. This is magnesium and this is neon. Neon is present in second period and magnesium in third period. Neon is on the extreme right and magnesium is in the second group. Okay, as we know that ionization energies from left to right increases, and the 0 group or the 8 group has the 8A group has the highest value of the ionization energy, so which means neon will have such a high value. And as we shift to the lower period, the ionization energy decreases down the group. As we increase the number of shell, the ionization energy decreases. So definitely all the element just below the neon will have smaller ionization energy. But again, there is a problem that neon is magnesium is not right below the neon. Instead, it is on the left side, and the ionization energies on the left side have definitely a smaller ionization energy, and it keeps increasing from left to right. Ionization energy increase from left to right, and from top to bottom it decreases. So considering that neon has such a large value of ionization energy as compared to magnesium, so magnesium will definitely have smaller ionization energy. although it is somewhat larger than sodium, but still it is at a lower shell, it is at a lower period number, so that's why ionization energy will be less. So from here we can check that neon has larger ionization energy than magnesium, so the option D becomes the right one. Now moving to the next question, number 5. Arsenic forms a compound with fluorine. In this compound, the arsenic atom has no lone pair of electrons and there are no dative bonds. And then selenium also forms a compound with fluorine. In this compound, the selenium atom has no lone pair of electrons and there are no dative bonds. So we have to determine which compounds contains different bond angles, although 180 degree is considered to be ignored. So in this case we need to find which different angles are present in these compounds. Before moving on to this question, I want to show the structures of these compounds from another website. I will put the link in the description section, from where you can also keep exercise. You can keep exercising your question from here. This is the website of Symmetry Otterbein. Here in this, on the screen, you can see that this is a structure, and this structure is simply the structure of the arsenic compound when it forms bond with the fluorine. Basically, arsenic is present in group number 5A, and the other element, selenium, is present in group number 6A. The arsenic is making bonds with the fluorine, so it is just like phosphorus, which makes 5 bonds with the fluorine atom. So arsenic is making 5 bonds with the fluorine. However, it is difficult to visualize what kind of structure will it make, so I'm showing you here. This is the structure of the, just like the structure of the arsenic bonded with the 5 fluorine atoms. You can consider that they are 5 fluorine, but out of these 5, 2 are green color fluorine atoms and 3 are blue color fluorine atoms. Now what's the difference between these different colors? You can see that these the ones which are green color are totally vertical to each other. However, these blue colored fluorine atoms are horizontally plane, they are present in the horizontal plane, and green colored fluorine atoms are in the vertical plane. So I'm going to write the angles here. According to the statement, the question said that the angle of 180 degree will be ignored. So this angle will be ignored, and it means we need to consider another angle. So the other angle over here is the angle from this green to this blue. Now we can see here that it is totally as on the right angle, so my right angle is 90 degree. Now come to the structure. On this structure you can see that these blue colored are just like in the form of the fan shape. These are 3 vertices of a triangle. So what we can say about them, that these 3 blue colored fluorine atoms will have an angle of 120 degree between them. So there is 120 degree of these 3 blue colored fluorine atoms. So in this case we got 2 angles over here. Now we have to check about the selenium molecule as well. Before going into description of the selenium compound, I want to share with you students that I have worked on the worksheets of whole AS chemistry as well as A2 chemistry. On the screen you can see that this is a topical worksheet of MCQs of unit 1. I have compiled questions from 2012 up to 2023. Here you can see the question is starting from May-June 2012, and the questions are very much refined from this unit of atomic structure. These questions are very much for your practice, and then the quantity of these questions is 88 question, and the last question is from 2023 May-June exam series. After MCQs questions then comes a mark scheme. On this mark scheme you can find the location, which is the MH photocopy. It is present in different areas in Pakistan, in F10 Markaz Islamabad, PWD Islamabad, Badgeton phase 7 Sadr, DHA phase 2 Lahore. It is also present there, and its contact number is given. After mark scheme comes the exam report. On exam report there are some questions given, the explanation of some questions are given which are very much tricky for the students to attempt. So it is very well defined topical worksheet, and you can find similar MCQs for all the 22 chapters of the AS. And after this the paper 2 of the same unit 1, you can find questions well defined again. These are the questions, and after the questions are over you can find the mark scheme of the questions. Here are all the mark scheme, and when this mark scheme is over you can find the section of the examiner report of all the questions and their parts. So I have compiled these kind of worksheet for all the chapters, and these questions are also ranging from 2016, 15 or 14 up to 2023. This is the last question in this worksheet. So these kind of worksheets, topical worksheets, are available for all the 22 chapters, both P1 and P2 of AS, as well as I have the worksheets of the paper 4 of A2 chemistry, and they are also again same number of exam series questions. So if any one of you want to practice the question, he or she can contact me on my WhatsApp number given on the screen or in the description. I will give them my topical worksheets in the PDF or soft form, and if you want to get them in the hard form directly, you can approach the MH photocopy, of which I have mentioned the location and the phone number. Now let's come back to the second compound, the compound of the selenium. Now here this is the structure of the selenium bonded with the 6 fullerene atoms. How is it so? Selenium group number is present in group number 6, so it means selenium will be bonded with 6 fullerene atoms. You can either draw a structure like this, which is called octahedral, or you can also draw a structure like this. So in total there are 6 fullerene atoms bonded with a central selenium atom. Now we have to check the angles present in it. So this is the compound of the selenium, and you can see that all of the atoms are same. They are all fullerene atoms. Now we have to find the angles between different bonds. Okay, so to calculate or to find the bond, this is the compound, and we are going to check the angles. So if we find this angle, then it will come out to be 180 degree, which is considered to be ignored, that is not considered. Now the angle between this atom and this atom, this one is vertical and the other one is horizontal. is in the horizontal plane, so the angle between the horizontal and vertical will come out to be 90 degree. So these are in the 90 degree angle. And you can also check that these atoms which are present horizontally, there are 4 atoms which are present on the horizontal axis. You can see that they are also present at 190, they are present at 90 degree. So the angle between them is also 90 degree. So I can say this is also a 90 degree angle. So what we see here, that both the angles are 90 degree. So considering these two molecules together, we can see that the arsenic compound has 2 different types of the angles present in its molecule, whereas selenium molecule does not have 2 different types of the angles present in it. So there is 90 degree and 120 degree present in arsenic, and there is just 90 degree angle present in selenium. So the correct option in which we needed to find was option B. Now question number 6. The structure of Borazole is given and we have to find these values. Okay, now for this purpose we need to recall some of the structures which we have studied in our literature. We studied that when there are 3 bond pairs, then angle is or the shape is considered as planar. When there are just 3 bond pairs and no lone pairs, no lone pair and 3 bond pairs, the structure is planar. When there are 2 bonding pairs and no lone pair, the structure is again planar and it is linear. So we have to consider these types of the shapes to find out the planar or non-planar structure. In this structure, we can see that nitrogen is making bonds with 1 hydrogen and 2 bromine atoms. Here this is 1 bond pair, this is 2nd bond pair, and these 2 single bonds, these 2 are basically a double covalent bond, and this double covalent bond will be considered as a 1 bond. So we can say that nitrogen has 3 bonding pairs. So 3 bonding pair for nitrogen will give it as a trigonal planar structure, which means it is a planar molecule. It is a planar structure with respect to nitrogen atom. Now we have to check for the bromine as well. For bromine, it is clearly seen that this boron is also making 3 bonds, 1 with hydrogen and 1 with nitrogen and another 1 with the nitrogen. Again, it is also considered as compound central molecule containing 3 bonding pairs. So it is also a planar with respect to boron. As I told you about the nitrogen, that it had 3 bonding pairs, we also needed to see if it contains any lone pair. So no, nitrogen doesn't contain any lone pair here. Although we can see there is a positive sign here and it should match with the NH4 positive, but in case of ammonium ion, there were 4 bonds or 4 bonding pairs, and as a result of this the structure was tetrahedral. And keep in mind that tetrahedral is a non-planar structure. It is not a planar structure. However, in the case of boron or nitrogen, there were 3 bonding pairs and the structure becomes planar, which comes from the word trigonal planar. So from the given column, we can say that it is a planar structure both with respect to nitrogen and with respect to boron. Now we have to calculate how many pi electrons are present. each double covalent bond is considered as 1 sigma and 1 pi bond. For every one double covalent bond, there is a 1 sigma bond and 1 pi bond. Now here we find 3 double covalent bonds, which means there will be 3 pi bonds present, and within 1 pi bond there are 2 electrons involved. When we have 3 pi bonds, we will multiply with 2, so 3 times 2 will give 6. So electrons involved in pi bonds are 6. So considering 2 ticks in this question, the right option becomes D option. That's the right answer. Now moving to the next question, question number 7. This question looks to be very difficult because of the including of a picture which never came in the previous questions in history. So it seems to be very difficult question, but in actual it is not. It is very simple question and very easy. Okay, the question is, the diagram shows apparatus used to find the relative molecular mass of volatile liquid, and for this liquid we were given the mass here, so it is the mass. It also contains the volume of the gas present, and the temperature is given over here and pressure is given over here. So all the variables to find the value of the MR in this question is given. This is the relation which we need to use here. PV is equal to nRT, and from here we can modify this equation into PV is equal to M or MR into RT. The question states to find out the MR, so MR will become MRT divided by PV. We need to substitute the values of all these variables to find the MR. Okay, now in this question the mass is given in, then we also know the value of the capital R, which is the general gas constant. Its value is fixed. Then the temperature is given in Kelvin, and we do not need to convert this value into another unit. Lastly, we need to check the value of the volume here. The volume is given in 85 cm cube and the pressure given in Pascal. We have to recall that there is a equivalency ratio of pressure volume in terms of the units. If the volume I can say for dm cube volume, the unit of the pressure should become the kilopascal, and for meter cube of the volume the pressure should become Pascal. Now having said that the equivalency is meter cube and Pascal, we need to convert the units of the volume. First of all, I will convert this 85 cm cube into the dm cube. So divided by 1000 will give me the value of 0.085 dm cube. And even after converting this value or this unit into the unit of meter cube, I will have to divide by even another 1000. So I will get 8.5 into 10 raised to power minus 6 meter cube. Okay, so I have converted this cm cube into the dm cube as well as in the meter cube. Now I have to convert this pressure unit of Pascal into kilopascal. So divided by 1000 will give me 101.3 kilopascal. So I have now converted both the Pascal as well as meter cube. Now I have to substitute these values into the given relation upward. So I will get Mr is equivalent to mass, the value is 0.1 times gas constant 8.31 times temperature, which is 400 Kelvin, divided by, if I take the value of pressure in terms of the kilopascals, I will get 101.3, and the value of volume in terms of the meter cube, I will get 8.5 into 10 raised to power minus 6. So this is the expression I get after proper conversion of the units. So looking at the options here, I see that this is the same expression in the numerator, and in the denominator this is the same expression. So that's why the correct option becomes the C. Now next question number 8. The question number 8 is based upon two tables, and we have to match the properties of the compounds in the first table with the compounds given in the second table. Alright, here in this question we are given the four compound W, X, Y, Z, and they are the properties here. Here W has these properties. Its melting point is high, boiling point is high, electrical conductivity. If you can't remember these values, then you can basically select the compound on the basis of these three columns. These will be sufficient to approach to the right answer. So let's see about the W. It says that W has electrical conductivity in solid form as poor, and as liquid form of liquid is good, and when it is in water it is also good. In liquid it means it says the molten form, and in water it means the aqueous form. So both in molten and aqueous form the electrical conductivity is good, but in case of solid form the electrical conductivity is not good. So in W we have the two compounds MgO and NaF, and both are ionic compounds, and both of these compounds totally agrees with these three properties. Both the compounds agree because they are both ionic compounds, so we have to tick all of them. Then about the X. X contains two compounds. This is the organic compound, and the other one is the inorganic compound, and it is an acid, it is a strong acid, and C2H5Br is a halogenalkene. It is, specifically speaking, it is bromoethene. So now we have to check the properties. So I'm going to check these last three columns. Electrical conductivity of solid is poor, liquid is also poor, and in water it is insoluble. So we can see here that in this case both the solid electrical conductivity and liquid conductivity of these both compound is totally agree with these two compounds. However, the last column says that it is insoluble. Electrical conductivity in water means it is insoluble, which means it doesn't dissolve in water. However, we know that HCl can dissolve in water. HCl can dissolve in water, and because of that it has a good electrical conductivity. So we can see that the correct option is correct option becomes the C2H5Br, because this compound does not dissolve in water, however HCl can. So I have to tick these two options. Now in the fourth column, Y have conductivity good in solid, liquid is called good but insoluble. So we can see here that in Y we are given four compounds. One of them is a very strong, reactive metal, and the other one is a very less reactive metal as compared to potassium. So the solubility in water is basically it means that both the metals over here, they are not soluble in water, they are not reacting with the water. but we know about the potassium. Potassium is a very good and it shows a very good reaction with water, because all the group 1 metals are very reactive, so it should show us a very violent reaction. So if it is insoluble over here, it means it should be iron, not potassium. So I will select iron over here. So I got these options correct, iron. And then in the last column, it is we have the properties of poor electrical conductivity in solid and good poor electric in liquid and insoluble in water. So here we have two options, aluminum oxide and silicon oxide. Aluminum oxide is an ionic compound and it can be dissolved in water. Aluminum oxide can dissolve in water, and silicon oxide is not soluble in water. It is a giant covalent structure, and that's why it cannot dissolve in water. Moreover, we know that electrical conductivity solid is poor for ionic compound and it is poor for the liquid form, because ionic compound of this type is less reactive, is dissolved in water. Sorry, in other words, even in the liquid form it has not such a good electrical. What I mean to say that for the third column we say electrical conductivity in solid form, in the liquid form is poor, which means it is a silicon oxide which is not showing the electrical conductivity even in its liquid form, and it is also showing less poor electricity in case of solid, and also it is insoluble in water. So the correct option in the last column becomes the silicon dioxide. So we can now look at here that all the options of the C are ticked over here. So the correct option is C. Now the next question, the operator is used to determine a value for the enthalpy of combustion of butane. This compound is given. We are given that the mass of 1 cm³ water is basically 1 gram. Then we are given the table of the this experiment in which the temperatures are given and the measurements of masses are given. Then we are given the relative molecular mass of the compound which is burned in this apparatus. We have to determine the enthalpy value. Now for this question again we need to do the calculations. Before continuing the question, I want to tell you that I have worked upon the topical worksheets of all the units of AS chemistry. You can see on the screen that this is the worksheet of MCQs of first unit, and I have designed the same worksheet for all the units of the AS. These are the MCQs. So I have compiled from 2012 up to 2023, and you can see that there are some questions which are repeated, and there are so many questions which are repeated, like this question is repeated 4 times in the previous exam series, and there are some questions which are showing that they are the part of the exam report. For this purpose I have changed their format like this one. These questions are those which are present in the examiner report, for which you can read the examiner report to get to the right answer as an explanation. And here in this topical worksheet you can find there are 88 questions. After these 88 questions come the mark scheme, and after the mark scheme come the section of the examiner report. In some selected questions are mentioned for because they are the part of the examiner report. The same design has been made for all the rest of the chapters of the first unit. The rest of the units of the whole AS chemistry. And you can get these worksheet in PDF form or soft form from me directly, or you can get the hard form from this shop which I have mentioned over here, MH Photocopy, the name of the shop, present in the F10 Medical Islamabad, PWD Islamabad, Veriton Phase 7 Rawalpindi, Southern Rawalpindi, and it is also present in DHA Phase 2 Lahore, and phone number is present here. Then I have also worked on the paper 2 of the same units. You can see the design of the worksheet. This is the structured questions or paper 2 of the same chapter. There are so many questions again. For this I have worked on the question which are in total there are 29 questions of this unit 1, and they also terminate at May-June 23 exam series. And after this section comes the mark scheme, and after the mark scheme comes the exam report section. So in this way you can have a very good practice of all the chapters of AS. Moreover, I have also designed the worksheets for paper 4 of the A2. So if any of you want these worksheets in soft form or PDF form, they can contact me directly through my WhatsApp number, which you can see on the screen as well as in the description section. Now let's get back to the question which we are doing. This question needs this formula to be used. Enthalpy is minus mc delta T over n into 1000. So we need to find all the values here, and then we can substitute the values to get to the right answer. Here in this diagram you can see that the volume of the water is 175 cm cube, and we also know that the density of the water is 1 gram per 1 cm cube, which means 1 gram will have a volume of 1 cm cube, or 1 cm cube will have a mass of 1 gram. So if the water is 1 cm cube, it means its mass is also 175 gram. Now after this we need to find the temperature, this delta T. For this purpose we need two temperatures. From the table we can find that these are the two temperatures, temperature I, which is initial, and temperature F, the final. Delta T is basically the final minus initial temperature, and I have done this working here. Now we have also calculated the temperature change. After that we need to find the mass of the compound present in it, which is used or which is burned. Butanol is a compound here. Here the masses are given for burner as well as butanol, the initial mass, and after the reaction was completed or done, the final mass was given for burner plus butanol. So we can take their difference as well. Now here we will take the value of Mi minus M2, because initially the mass was higher, and then after reaction was done, some of the amount of butanol was burned, so we get less value of mass. Now let's take their difference. Mass of butanol is Mi minus Mf, so we get this mass. It is 0.49 gram. Now some students get confused which mass will be used in the expression of the delta H. So mind it that we are using this value of the mass, which is of water. Why is it so? Because the reaction is being carried out in the aqueous solution, or in other words, the reaction is being carried out in over here, that this is a mass of the water which is basically gets heated up, and because of that the temperature rises. So we need to find the value of this water which is being heated up, and the mass of the butanol is used to calculate the number of moles, and that number of moles which is given here in this expression. Now as we have found the value of the butanol, we need to calculate the number of moles as well. To find the number of moles, we should know its MR value, which is given here. So let's take its number of moles as well. The number of moles is mass over MR value, it is this value 0.06621. So we have calculated the value of the mole as well. Now we have to simply put all the values into the expression. The delta H is minus mc delta T. This is minus m, so this is m, the mass of the water. This is C, the heat capacity constant, and this is delta T. This is the n value, the mole of the butanol, and this is 1000. So after doing the calculation, you get this answer 2596.32, which is rounded off to 2600, and so the correct option becomes the C. That's the right answer. Then next question. The next question is highlighted here, and as I told in my previous two videos that I have highlighted all those questions along with the reference from which these questions were taken. These are basically the repeated questions from the previous exam series, and you can find the videos of these questions from the description of this video, because the previously these questions were already solved by some other either students or teachers. So I have mentioned the links and the duration at which, or the time span at which you can find the answer to these questions. So I'm skipping these questions because it's of no use to again solve these questions when they are already solved by some other teachers. So you can find the links in the description. Now moving to the next question, number 11. In which direction the oxidation number of chlorine changed by the largest amount? Which means we have to find where there is a greatest change in the oxidation number of chlorine. So for this purpose, we definitely need to calculate the oxidation numbers of chlorine in all the four options given. Only then we can get to the right answer. So in option A, the oxidation number on the chlorine will be +5 over here, because oxygen is -2, -2 times 3 is -6, and this potassium is +1. So that's why the charge on the chlorine will be +5, and the charge on this chlorine is very easy, it is -1. In B option, this ClO is negative, which means oxygen has -2 and the chlorine will have +1. So +1 -2 will give the answer -1. Here it is already mentioned -1, and here -2 times 2 will give -4. So the chlorine should have +3. That's why you get the value of -1. Here it is 0, here it is -1, and here it is +1. Now over here it is +3. Here it is 0, it is -1 here, and it is +4 here. Alright, I have shown all the oxidation numbers of the chlorine in all these options. Now we need to check the largest change in the oxidation number. So here for this purpose you can see that this +5 is converting into the -1, so it means there is a change of 6. From here you can find the change is from +1 to -1 over here, and it is +1 to +3 over here. And in the C option, the change is from 0 to -1 and 0 to +1, and in the last option it is from +3 to 0, and the second case -1, and also +3 to +4. Or you can also find for 0 to -1 and 0 to +4. So we have seen all these changes, but here the largest change comes in option A, where we can see the change of 6 value. All the rest of the option will give smaller values than this. Like for example in B we get from +1 to -1. It is said to be a change of 2, and from +1 to +3 again it is 2, it is 1, here it is again 1. So the correct option becomes A. So just by calculating the oxidation numbers we arrive to the right answer. Now the next question, number 12. Question number 12 is again highlighted here, as I told before that I have already put the YouTube links of the questions which are already attempted by someone else, and there are some questions which are already attempted, and these are repeated from the previous years. Now the question number 13. The question number 13 says that there is a disproportionation reaction in which HNO2 converts into two compounds. HNO2 converts into HNO3 and NO, and there is no other product which is produced, and there is no other element other than nitrogen which is oxidized or reduced. This question is kind of tricky, and I hope this question will become a part of the examiner code. Now let's start solving it. We need to first of all construct the equation here. So I'm going to construct equation. This is the reactant HNO2, and it produces the HNO3, which is a nitric acid, and the next product is the NO. Okay, now we need to find the values of W, U and V, which are basically the coefficients here. So the coefficient for the HNO2 is W, for HNO3 is U, and for NO is V. Okay, now here we need to find the coefficients. Coefficients mean there are some kind of balancing here. This is the example of the oxidation reduction reaction, which means we need to consider the electrons being lost and gained here. So how do we know which electrons and where the electrons are being lost and where the electrons are being gained? So this purpose, they said that it's just nitrogen element which is showing the change in the oxidation number. So I have to put the oxidation numbers of all the nitrogens present in this reaction. It is +3 in reactant, it is +5 in HNO3, and it is +2 over here. Now we have seen that there is change, and nitrogen is the only element showing the disproportionation here. Okay, now it is changing from +3 to +5 here, and it is changing from +3 to +2 here. So what it means, the change in the electrons, +3 to +5 means it is losing 2 electrons. So I will write -2 electrons. This minus represents the loss of electrons. There are 2 loss of electrons, and in the HNO2 to NO there is a change of 1 oxidation number, and it is showing it is getting reduced here. So which means it is gaining 1 electron. So I will write 1 electron plus. It is gaining 1 electron when it moves from HNO2 to NO. Now we have to balance these electrons. It can be clearly seen that we need to multiply this 1 electron with 2 to balance electrons. Since there are 2 electrons which are losing and 1 electron which is being gained, so we have to balance them. So I will multiply this electron with number 2, and the electron which are lost should be multiplied by 1. So I have done this. Now when we write the electron with any number, it means we have to multiply that number on the chemical equation as well. So here I should multiply this NO with 2 and not the HNO2, because HNO2 has 2 further products, and I cannot multiply this 2 with the reactant as well, because reactant also showing the reduction and the oxidation. But I have to multiply this 2 with the product where it was the finished, where it was finished. So I have multiplied this 2. Now for HNO3 I have to multiply it with 1, because it was multiplied with 1 number here, and for this purpose I have multiplied it with 1. Now I have done this thing. Okay, although according to this form we can see that the hydrogen and that the oxygen atoms are not being balanced, or my mistake, we can see that the nitrogen atom is not being balanced here, that there are 3 nitrogen atoms on the product side and there is just 1 nitrogen atom. But let's check the options given. According to here, the value of V is clearly seen to be 2, so this option is correct. And for U, the correct option is 1. That's what we have done here. To balance the electrons, we needed to multiply these numbers with the respective products, but we do not know which number should be given to W, because if you apply all these combinations, you can try it by yourself, that if you apply all these combinations, you will not be able to balance the any one of the elements. In most of the cases, it is the apart from option A, the rest of the option will always imbalance the number of the hydrogen atoms or nitrogen atoms. So even if you check all of these options, you will not be properly balance all the atoms of all the elements. So it means that we need to compromise on that balancing, but we need to check which element should give us the right answer. So considering these 2 ticks over here, this is the maximum ticks we have get in a single row. It shows that the right answer would be B. Now if I apply this combination 3, 1, 2, let's suppose it is 3 and 1 and 2 already given there. We get 3 hydrogens here, but we get 1 hydrogen on the product side. So in terms of hydrogen, it is not balanced, and in terms of the nitrogen, it is balanced, and oxygens are not balanced as well, because there are 6 oxygens here and there are 3 over here and 2 over here, 5. So 5 oxygens here. So both hydrogens and oxygens are not balanced even if we select the option B, but we need to at least balance the number of the electrons which are to be balanced, because it is the example of the oxidation reduction reaction, for which the electrons lost and gained should at every cost must be balanced. That's our main priorities. So just by balancing the electrons, we got U and V. We found the values of the U and V, and these were only row with 2 consecutive ticks, so that's why the B is the right answer. Now next question, number 14. This question is also kind of tricky and will, I guess, become part of exam report. The question says that we have this equation in which X is decomposing. Then the X was present at pressure P, and after the equilibrium was established, the elements Y and Z, after equilibrium was established, the pressure of X became 1/7P. Now we have to calculate Kp. Now in this question we need to determine Kp, so for which means we need to find the pressure values of all the 3 substances in equilibrium. The X value is already given, but we need to find the pressure expression for Y and Z. So it means we need to do the working, and I have done the working already. Now we know that for equilibrium we have 2 different states, the initial state and the final state, the initial and the equilibrium state or stage. At initial state, the element X or the gas X had this pressure P, and at that time the pressures of Y and Z were 0, because there were no formation of Y and 0. But when equilibrium was established, then we know that the pressure value for X became 1/7P. So the value of X is given, but we need to find the pressure values for Y and Z. To find that value, we need to do this calculation. This is the value of the initial pressure of X, and this is the value of the equilibrium value of the X. These values belong to X. So we know that there was formation of the product, but we need to find how much amount of the product was formed. To find that, we need to check how much amount of the X was used. That is the amount of the amount of the X which is used or reacted. So it is simply a mass here. We are given P and we have 1/7 P, so doing the calculation we get 6/7 P. Now this is the value of the formation of the products in equilibrium. This much amount of the products were made when the equilibrium was established. So we can say that X was converted from pressure, from one value of pressure or 1 unit of pressure into 1/7 of pressure, whereas Y and Z, which were the products, were converted from 0 at initial stage to the equilibrium stage of 6/7 P. This is the amount of whole Y and Z combined. But here in this expression you can see that there is 1 mole of the X and there are 1 mole of Y and 1 mole of Z, which means this 1 mole of the X has been divided into half in both Y and Z. So both Y and Z are taking half values of the X amount, because there are two products with 1 mole of each, so we have to calculate their different or their separate pressure values. So it means that the Y will get half of this value, the half of this 6 is 3, and the other half, which is Z, will get 3/7. So both Y and Z are getting half of the 6/7, so it becomes 3/7. Now we have calculated the values of both X and Y, so I can write this expression, or I can write the values below their symbols. So 1/7 for X in the equilibrium stage, and 3/7 for Y, 3/7 for the Z. Now this is a KP expression. KP expression is written in terms of the partial pressures. So partial pressure of Y times Z divided by partial pressure of X. Now we have to substitute the values here. So after substituting the values, we get this expression. Now here in this expression, we can simply cancel which are same here. Pressures of the numerator and denominator, one of these P are cancelled, and this 7 is also cancelled with the denominator 7, because you can simply take this 7 into the upside in the upper numerator, and these two p's can come in the denominator, and you can simply cancel them in the same way. Now after doing this cancellation, we get this expression 3 into 3p/7 over 1. Now this means this 3 into 3 will multiply and you will get 9p/7, and that's why the correct option becomes option B, which is 9/7p. And this, I hope, question is now fully understood by every one of you. Now the next question, number 15. In this diagram, we are provided 3 different peaks. The X peak is considered as the standard for the initial position for the particles. We need to find which of the curves Z and Y are correct. Now if we look at here in the options, that EA2 is the activation energy at a higher temperature. So EA2 is not changed at higher temperature, because it only changes the presence of the catalyst. If it was present here on X at this position, then after using the catalyst, it should move to the left side over here, but not on the basis of the temperature. So that's why the option A becomes the incorrect option. Now Option B says that E2 is activation energy at a lower temperature. Now, at the lower temperature, we get this graph of Y. Y is the graph when it was when the temperature was lowered. Then we got this Y graph. Now, at Y graph, the EA2 is not there. Or in case of this, we can see that EA2 has been moved over here. You can have an idea of the Boltzmann distribution curve from my notes. These are my notes. If any student is interested, he or she can also contact me for these notes made by me, written by me. You can see here that we have this distribution curve where the reaction with a high activation is given here and with low activation is given here, and this activation is changed on the presence or on the absence of the catalyst. When we put the catalyst, then the activation energy shifts toward the left side, and if we do not have catalyst, it is on the right side, as we can see in this graph as well. Now this is the graph which shows that when catalyst was used and when catalyst was not used. When catalyst was used, the value, the vertical line shifted to the left, and when catalyst was not used, the vertical line shifted to the right. So whereas the effect of the temperature is shown in this graph, where you can see that when the temperature is increased on the Boltzmann curve, the curve shifts to the right and to the downward side. So it is shifting from left to right and also from up to down. So putting these two concepts together, we can see that the B option, as it says that the EA2 is activation energy at lower temperature. What we know that the activation energy does not change upon change in the temperature. If EA1 is there at this point, then it should stay at here. It should not change upon temperature. If we link in the temperature, then EA1 value should remain here. This EA2 should only be present here when the catalyst was used, not in terms of the temperature. So this option B also becomes incorrect. I am saying again that activation energy can only shift its value because of the use of catalyst and not because of the temperature, because temperature has only the effect in its value of the shift, the peak value, the most probable energy value. This is the most probable energy value. Then the D option says that Z is a Boltzmann distribution curve at a higher temperature. Again, we need to link or refer to the initial Boltzmann curve, which is X. This is X, and we have to check its effect on the temperature. When the temperature was higher, then the peak should move to the right as well as downside. However, the peak of the Z remains at the same height, or in fact we can see with more detail, and if we deeply see it, the peak value is been getting more upward, not downward. So it is totally incorrect option. Now the option Y says that it is a Boltzmann distribution at a lower temperature. So again, compare the peaks of X with Y. Now if we consider that the Y should have a lower temperature, and as a result its peak should move upward, also to the left side. So both the conditions are fulfilled here, that the peak of the Y is higher and towards the left side of the X. So as a result, this is the correct option. So C is the right answer. Now next question, number 16. We have magnesium, aluminium, silicon. Now for this question I have although put the highlight, and you can see that this question was repeated 2 times in the previous exam series. Both are from 2020. but there is a problem here that this question is not actually the same as in the previous years, because in some questions they have either asked a question on the in other words, they have asked a question in which two combinations are same like in this question, but the third combination is not the same, or in another question these two combinations are same, let's suppose, but this is not the one. So I have although put the references here, but you will not find exactly same question in which all these three combinations are present all together. So I'm going to solve this question by myself right now. Okay, we have these options of MgO, Al2 and SiO2. We have to match their properties. When their properties will match, we will be able to select the right option from A, B, C, D. Okay, so for this to approach to the right answer, we need to have some literature in our possession. So I'm going to show you my notes on this topic. Okay, so this is a page from my notes of AS chemistry, as I have previously mentioned that I have written the notes of whole AS chemistry, and if anyone of you is interested, he or she can ask for these notes. Okay, here I have compiled all the properties of the period number 3 elements. Now here we need to check the properties of these 3 elements at the same time. So I'm going to make it clear. We need to tick all the relevant properties, and all those properties which are clear from this table will be checked, whereas those which are not in this table will be separately discussed. So according to this table, the first column of the MgO is first checked. It says that its property is basic, so we need to check from this table in the column of the magnesium. This is magnesium, so the magnesium has the basic property. Yes, it has a basic property here, so yes, we can select this option, and so this is right. Then it says has a giant ionic structure, so I have to check this. This is the structure title, and in terms of its oxide, its structure is giant ionic. That is correct. High melting point. Now I have to check its melting point values over here and in oxide as well. Although I don't see high or low words here, but I can see that the value is very much higher. 2800 is such a large value, which means it does have a high melting point. Then reaction with water. The reaction with water is not as such given because it only shows white solid gives colorless solution, so it is not the one which I need here, slight reaction or no reaction. So I will check this topic separately. For the moment I'm leaving this property. Now let's move to the next compound, aluminium oxide. The aluminium oxide is for this aluminium we have this aluminum oxide, and we need to check its acid base nature. So it is amphoteric as given here, amphoteric, which means it is just amphoteric. Then the structure of aluminum oxide, simple molecular. So let's move to the structure part. Now aluminum oxide has this giant structure, giant ionic structure. It is not simple molecular, so this means it becomes incorrect. Then comes the melting point. So in melting point its value is 2070, which means still a large value. So yes, I can put it as a high value. I am leaving this reaction with water property. Now move to the silicon oxide. Now under the silicon oxide I have to check its properties. According to acid base nature, its property is acidic. However, in this question it is said amphoteric, which is incorrect. Now about the structure of the silicon dioxide, it says giant ionic, whereas in the silicon the structure is giant covalent, not the giant ionic. So this giant ionic becomes incorrect. And then its melting point, silicon dioxide has a considerable large value, 1710. So yes, it has a high melting point, but in this question it says low melting point, which means it is incorrect. Now I have checked these three properties of all these three compounds. Now I have to check separately the reaction with water. Now I'm going to use my notes again for this purpose. Now I'm back to my notes. You can see that in my notes I have shown the properties of manganese, shown the properties of reaction of water with the oxides of period 3 elements. So here we can see that magnesium is only slightly soluble here. It does react but slightly reacts. So we can select this option right. And then if we go to the aluminum oxide, it says that it does not react or dissolve in water. So we can also tick this option, no reaction with water. And for silicon oxide, if I move downward, I can see that with silicon it also insoluble in water. So yes, we can also put this as tick. I have also summarized this in this table. You can see this is a table in which magnesium shows a reaction, aluminium shows no reaction, and silicon oxide also doesn't show reaction, and it said insoluble in water, insoluble in water. So that's why all these ticks are made here. Now looking at all the options, we can see that that's the only right option of D, which has all the ticks on, which have all the ticks in its horizontal row. So that's the right option. Now question number 17 is highlighted, which means it has been repeated question and video has already been made. I have put the link in the description section. Now question number 18. X and Y are two elements from period 3 of the periodic table. Element X has a higher electrical conductivity, and then Y has higher melting point than X. Now we have to calculate which compound is present because of the formation of X and Y combination. So we have to find the first of all identify these elements, and after identifying we can easily check which compound is it. Okay, I'm going to write here the combinations of X and Y elements. X, I can say, can be magnesium, although I can also say Y is the magnesium, but if I consider it as magnesium, then I will select the other opposite element as Y. So it can be magnesium, and silicon. I have selected 4 elements from these combinations as X, and I am going to select 4 options from the other side as well for Y. So for Y it can be sulfur, silicon from this B option, and from the C option it can be chloride, and from the D option it is again chloride. Okay, now according to this, it says that X has a higher electrical conductivity than Y element. So I can check this in the first combination. In the first combination, it is the magnesium which has definitely a higher melting point. If I consider electrical conductivity in terms of electrical conductivity and as well in terms of melting point. In terms of electrical conductivity, magnesium does have a higher electrical conductivity because it is a metal. Yes, in terms of this it has. But in terms of the other property which says that Y must have a higher melting point than X, then we can see that sulfur is a non-metal, and for this purpose I have to look at the chart. Now this is a page from my lecture notes. On this page you can find there are 2 charts or three charts in which the properties of melting point and electrical conductivity are shown. So if I zoom it here, then in terms of the electrical conductivity, you can see that the magnesium has a higher electrical conductivity than sulfur, and in terms of the melting point, the magnesium has higher melting point than sulfur. So on this basis we can say that in terms of melting point, it is not the right relation or right order. Now moving to the next combination of magnesium and silicon. So let's get back to the charts here. Magnesium versus silicon. So in this case, magnesium has definitely a higher electrical conductivity than silicon. So I have seen that either you can check this graph or the second graph, because this is more reliable, or this is considerably less reliable, because all the values of sulfur, phosphorus, sulfur, chlorine, argon are horizontally and at zero value, but this has some higher value. So I will consider this graph. Now on this graph you can find that the electrical conductivity of magnesium is over here, and the electrical conductivity of the silicon is present here, so its value is lesser. So in the first case, when it said that according to the first relation that X must have higher electrical conductivity, so it becomes correct. Then about the second option, we say that Y should have higher melting point. So let's check the first graph. According to the first graph, silicon versus magnesium. So we can see that silicon has a higher melting point than the magnesium. So the second option becomes the correct one. This is correct because silicon does have a higher melting point than the magnesium. Now the third relation of sodium and chlorine. So let's check their combinations. Sodium and chlorine. In terms of the electrical conductivity, sodium has this electrical conductivity and chlorine has this. So it is correct that it has a higher electrical conductivity of X. And then about the melting point, so melting point of chlorine is smaller than the sodium, so it becomes incorrect. And for silicon and chlorine, in terms of the electrical conductivity, the silicon has quite higher value than chlorine, just slightly higher value than chlorine. Electrical conductivity of silicon is just quite larger than chlorine, so yes, it is correct. But in terms of the melting point, it says that chlorine should have higher melting point than silicon, which over here is incorrect because silicon has higher melting point than chlorine. So this becomes cross. So all the options are incorrect except for the combination of the magnesium and silicon. These two are correct. Now according to this, we need to find the formula, or we do not need the formula because there is just one single option in which there is a combination of magnesium and silicon combined. However, we can also derive this formula. For this purpose, we should know their charges. Magnesium is present in group number 2, so it has +2 charge. If it is plus, then silicon will definitely be -4. So when we construct the formula, we cross these values, not the charges. Their charges are crossed, and then we will get Mg4 and Si2, and if we take its empirical formula, then we will get Mg2Si. So that's why its correct formula is Mg2Si. Now question number 19. A sample of this 1 mole of anhydrous calcium nitrate is decomposed. We have to calculate what is the total amount of gas produced in this reaction. For this purpose, we must construct a chemical equation simply. So I'm writing the chemical equation of decomposition of calcium nitrate, and calcium nitrate decomposes into calcium oxide plus nitrogen dioxide 2NO2 plus oxygen as half of the mole. So I have this equation. We are given the value of the anhydrous calcium nitrate as 1 mole. Now this is a solid, and calcium oxide is a solid, nitrogen dioxide is a gas, oxygen is also a gas. We are supposed to find the amount of the gas produced, which means the amount of the products of nitrogen dioxide as gas and oxygen as a gas. So for this purpose we need to have their moles. That's what we have to find in this question. So I'm going to take the ratio of calcium nitrate ratio on nitrogen dioxide plus oxygen gas. I'm taking the ratio between that. So according to stoichiometry, there is 1 mole of calcium nitrate, and for the nitrogen dioxide there are 2 moles, and for oxygen there is half mole. So 2 plus half, it will come out to be 2.5. So 1 ratio 2.5, and that 1 is also considered in the data provided. So we do not need to do any further calculation, and that's our relation of the ratios. So there will be 2.5 moles of the both products combined, because these two are the gases over here. We needed to find the gases, we needed to find the values of these gases. Now next question number 20. This question number 20 is already attempted by someone else. I have given the link in the description as well as the comment section. Now question number 21, we have to select the right option. The first statement says that hydrogen bromide reduces concentrated sulfuric acid to form sulfur dioxide gas. Okay, here let's leave this option and move to the next option, B. Hydrogen bromide decomposes at a higher temperature than hydrogen chloride. No, it is incorrect, because hydrogen bromide includes the bromine and hydrogen chloride includes chlorine. The size of the bromine is higher than the atomic size of the chlorine, and as a result the bond distance of bromine, or the bond length of the bromine, is greater. The greater bond length means the temperature required for the breaking of the hydrogen bromide should be less. It should be lower value, not the higher value, because the bond distance of bond length of the HBr is greater than the bond length of the HCl. So it is incorrect. C. When hydrogen bromide gas is shaken with aqueous silver nitrate, yellow precipitate is formed. So it is incorrect. Either you can tell in terms of hydrogen bromide or in terms of its color. If it is bromide, then the color should be cream color. But however, this yellow color belongs to the iodine. If it is written iodine, iodide, then the yellow is correct. So in both ways it is incorrect. Then D. When hydrogen bromide gas is bubbled through aqueous iodine, the solution becomes colorless. Now here it means that the bromide ion is becoming oxidized. The bromide ion is getting oxidized into the bromine gas because of the iodide ion. However, it is incorrect, because bromine is more stronger oxidizing agent than the iodine. In terms of the oxidizing agent capacity or strength, bromide is more stronger oxidizing agent. So iodine cannot oxidize the bromide. So that's why this option is incorrect. Now option A says that a bromide ion reduces concentrated sulfuric acid. So yes, that is correct, that when HBr reacts with the sulfuric acid, then we do get the product of SO2. So that's why the correct option becomes A. Now next question number 22. Question number 22 says we are given this expression and another expression. We have to find which is the correct combination in terms of oxidation number and when reaction occurring when ICl reacts with water. So oxidation number of I in the ICl. So I can simply calculate values here. We know if we check the data section for the values of the electronegativity values of all the elements, then we see that chlorine has higher electronegativity than iodine. When we go down the group, electronegativity value decreases, which means chlorine has higher value and iodine has lesser value. So it also means that chlorine will have negative charge and iodine will have a positive charge. So considering that, we can select the option A and B here. Now the other table, the other column is for the reaction of ICl with water, and it says that the iodine atoms are oxidized to iodine, or the iodine atoms are oxidized to form HiO3. Now for this purpose I have to find the oxidation number of iodine in the second reaction. In the second reaction, I can write that this is +1 here as calculated before, and it becomes 0 over here, and it becomes +5 over here. So is it right that iodine atoms are oxidized to form I2? So from +1 to 0, it is not the oxidation, it is the reduction, not oxidation. So that's why this option becomes incorrect. And the second option says that iodine atoms are oxidized to form HiO3. So from ICl to HiO3, it does get oxidized. So yeah, that's a correct option. So the right option becomes B. Then next question number 23. NH4 reacts with NaOH in an aqueous solution. Which statement is correct? Now again we have to check all the statements. Let's start from B. The bond angle in nitrogen containing species remains unchanged. First, for this purpose we need to know the expression or the chemical reaction. The NH4Cl, when reacts, we have this reaction type here. We have to react NH4Cl with NaOH, and as a result we get NaCl plus NH3 plus H2O. This is the whole chemical reaction. Now option B says that the bond angle in nitrogen containing species remain unchanged. Okay, which means that we need to check the bond angles of all the nitrogen containing species here. Here we have one over here, which is the ammonium ion, and on the product side we have ammonia. In ammonium ion, if I write its structure, it is NH4 plus, which is nitrogen has 4 bonds here in 3-dimensional. It is the structure of this type. Now here the angle is 109.5 degree, and in ammonia the angle is 107.5 degree. So it does not remain unchanged. It is incorrect. So option B is incorrect. Then C says the ammonium ion acts as a base. Now here we can see that this is the sodium hydroxide, which is an alkali. So alkali is a base, not the ammonium ion. So moreover, ammonium ion is losing its proton That's why it converts into the ammonia after losing a proton. So it acts as an acid. It acts as an acid, not as a base. So this is incorrect. It acts as an acid. Then D option, the oxidation state of nitrogen increases in the reaction. Now for this purpose I need to calculate the values of the nitrogen in terms of oxidation number. In ammonium ion it is -3, and in ammonia it is still -3. So there is no change in the oxidation number of the nitrogen, so it does not increase or decrease, it remains the same. It is incorrect. So D is incorrect. Now comes the option A, the reaction gives rise to two different polar product molecules. So to find this we need to check that these are the products given here, the NaCl plus NH3 and H2O. Okay, now polar product molecules. Here this is an ionic compound, this is a simple molecule, and this is also a simple molecule, and it says molecules and as polar. So ammonia is yes a polar because it has a lone pair here. Water is also polar because it does even have the hydrogen bonding, although NH3 is also containing the hydrogen bonding. Both of them are containing hydrogen bonding, and it is there because of the presence of very great electronegative difference of hydrogen and the nitrogen oxygen elements. So yes, these are polar molecules, and water is also a polar molecule. So because of this reason this is a correct option. NaCl is not considered among these two because it is an ionic compound, and ionic compounds are never simple molecules. They are never simple. These are giant ionic compounds. So these two molecules means ammonia and water. So that's why the correct option becomes A. Then question number 24. This question is highlighted, which means it is a repeated question, as well as it is also solved and explained by someone else. I have given the link in the description section and as well as in comment section. Now comes question number 25. This question is part of the organic chemistry. So the questions of the organic chemistry starts purely from here. It says which alkane shows geometric isomerism. Okay, we need to have a displayed formula or structural formula of this compound to find the right answer. The cis geometric isomerism means it is a cis trans isomerism, and we have to look all the molecules here. So I'm going to draw the structure of the molecule A here. The molecule A, if it is written in terms of cis trans, then CH3, CH2, and then this CH2 is further polygonal CH2. Then I can write this carbon with double bond with another carbon. This carbon has hydrogen, and this carbon has two hydrogen atoms bonded. Now here you can see that these two are hydrogen atoms, so this does not fulfill the requirement of the cis trans isomerism, and that's why A option becomes incorrect. Now I'm going to write the structural formula of B molecule. It is CH3, CH2 bonded with carbon, which is for the carbon double bond, and this carbon has hydrogen here. This one has this hydrogen one, and this has methyl group here. Now in this compound we can see that there are two hydrogen atoms on one side, and there are alkyl groups on the other side. Although they are different, but they are definitely hydrocarbons, and they can be considered as alkyl groups. This is also alkyl, this one is also alkyl. So just because of the similarity, we can see that they are the same groups. So we can see that these can give us cis-trans isomerism, because these groups can interchange their positions to give cis. These are cis, and if their position are changed, they will give us trans. So that's why the correct option becomes B. So we do not need to find the structures of C and D. Then question number 26. What is the correct name of the major product of the reaction of HBr with this compound? Alright, we need to recall the reactions of the alkenes with the HBr or HCl compounds. These are the hydrohalogenation reactions of the alkenes, or addition reactions of the alkenes. Okay, this compound can be written in this form. I'm going to write its simple structure. There are 6 carbon atoms with a double bond on the 3rd position, and the methyl group is present on the 3rd position over here. This is the structure of this compound. Now we can now add the HBr in this molecule. So I'm going to add the HBr, H3CH2. This is the compound, and when we add HBr, then it will follow 2 routes. One route for the major product and the other one for the minor product. Because it is following the Markovnikov's rule, or the stability of the cations rule. We can say Markovnikov rule, or the stability of cations. Now, according to this rule, the stability of the tertiary cation is greater than secondary cation, and the stability of the secondary cation, tertiary cation, is written in this way. It has more stability than the secondary cation, and secondary cation has higher stability than the primary cation. So considering that, when we are adding HBr, then we will need to add hydrogen in this carbon, and bromine will be added on this carbon. So as a result, the product which will be obtained will be this one. This will have the bromine over here, and the hydrogen is added on the right carbon. So as a result, we get CH2 here. This CH is converted to CH2. Now this is a major product, but if we add in the other way around, then we will get the minor product, which means if I add the hydrogen on this carbon, and if I add the bromine on this carbon, then I will get this minor product here. So this is a minor product. So, but the question is saying find the name of the compound as a result of the major product, as the name of the major product. Find the name of the major product. So major product is this one, A. We can see its name. Bromine is on the position number 3, methyl is on the position number 3. So yeah, that's the right answer. Now question number 27. The alkane undergoes free radical substitution with chlorine. No CC bonds are broken. Find how many isomeric products, including positional and optical isomers, of this formula will be formed. Now this question is kind of tricky one, and for this purpose we need to draw all the structures which are formed as a result of the free radical substitution. Before discussing that question, I want to show you that I have compiled the topical worksheets of all the units of AS chemistry. You can see on the screen there, this is the topical worksheet of paper 1 MCQs of atomic structure. The questions are from 2012 up to 2023, and there are very questions defined here. You can find there are some lines shown which are showing there these questions are repeated. Some questions are even repeated 4 times here, and some questions with this type of different font shows that these questions are the part of the exam report, and the exam report questions are always tricky. So I have defined these questions. Now over here you can see that there are 88 questions. Now after and these end at 2023. You can find over here it ends at 2023. Now after these question section come the mark scheme here, and the mark scheme also shows the address from where these topic worksheets in the hard form can be obtained. This is the MS photocopy shop at F10 Medical Islamabad, PWT Islamabad, Barrier Phase 7, Sadr Rawalpindi, and then DHA Phase 2 Lahore, and the phone contact number is given. After this mark scheme comes the exam report, and the exam report contains the explanations of those tricky questions. So this is the same design for all the rest of the units of whole AS chemistry for the same years 2012 up to 2023. Then comes the structured question of the same chapter. First you will find the questions over here, and after these questions come the mark scheme of these questions over here. This is a section of the mark scheme of all these questions, and after these questions and comes the exam report, and after the mark scheme section comes the exam report section, where all the parts of the questions have the exam report shown. So this is the same design followed for all the chapters of this whole AS chemistry. I have also designed topical worksheets of the A2 chemistry for all chapters. And you can get these topical worksheets in SAW form or PDF form directly from me by contacting on my WhatsApp number given on the screen or in the comments and description section, or you can get these in the hard form from the already mentioned photocopier shop or MS photocopy. Now let's get back to the question we were about to attempt. Now for this question we have to draw the structure, so I have done the working. Now I'm just showing a simple structure of this compound with the carbons and chlorine atoms. We needed to add the we needed to do the free radical substitution reaction with just one chlorine atom to be added. So I have added one chlorine atom at this position, so it is considered as one isomer. And in the other case, in the other structure, I have added the chlorine on the second carbon atom. No, this is the second this is the second isomer, and I can now change its position to this carbon atom number 3, which is saying 3 because or I should say second, because numbering will start from right side because the branching is present near to this side. It is near to this side and is far from this side, so numbering will start from right to left. So that's why it is numbered like this. So on first case I have put the chlorine on the 4th position, then on the 3rd position, and then in this case I have put on the 2nd position. Now I can now even put on the branching, which means on the 1st position. So all the 4 positions have been replaced with have been substituted with the chlorine atom. They are carbon atom. There are 2 carbon atoms with position number 1 because these both are same. So either you put chlorine on this chlorine or on this chlorine, it means the same. Now we have to find we have found the positional isomers here. These 4 isomers were considered as positional isomers because according to definition positional isomer there will be a the difference of the position of the functional group on the carbon atoms. So these are all shown. Now we have to find the optical isomers as well. Now to find the optical isomers you need to look for the chiral carbons in these all of these structures. So let's start from the first isomer. I'm writing these as first, this one as second, this is as third, and this one as fourth isomer. Now check the first isomer. In the first isomer there are 3 hydrogen atoms with the carbon number 1. With the carbon number 2 there are 2 methyl groups bonded. With 3 there are 2 hydrogens. With 4 there are 3 hydrogens, so no chiral center there. On position number 2 there are 3 hydrogen atoms. On carbon number 2 there are 2 methyl groups. So but yeah, with the first isomer on carbon number 4 there were 2 hydrogen and 1 chlorine as this, and this whole group as second, another group. So these 2 hydrogen atoms are basically the same, so that's why no chiral center is present there. And on isomer number 2 if we consider this carbon on which chlorine is bonded, then this chlorine has 2 methyl groups on its sides, so that's why it is not a chiral center. So no chiral center over here. Now if we consider isomer number 3, then this carbon has 1 chlorine atom here and 1 methyl group over here. One of them is hydrogen and this is another whole group. So yes, we can say that this carbon does have the chiral center present on this carbon, so it has a chiral center here, whereas none of the other carbons contain the chiral centers. Now on the isomer number 4 I can check again. On isomer number 4 the one which is bonded with the chlorine has 2 hydrogen atoms on the either sides, so because of this it does not have chiral center here, and none of the other carbons contain any chiral center. So what we see that only one of these has the chiral center over here. So this direct means this compound will have 2 optical isomers. 2 optical isomers, which means I can say them as the 5th isomer and the 6th isomer, because there were already 4 isomers present on the basis of the positional functional group, but on the basis of chiral center there are another 2 optical isomers. So in total there are now 6, so that's why the correct option becomes 6. Now the next question, number 28. This question has 3 different variants. It means this question is repeated 3 times in the past papers. Now this question is already solved by 7. I have given the links of the YouTube videos in the description sections below. Then question number 29. This question is although highlighted, but this question is not exactly the same as in these provided exam series, because some statements were different and some options were also different. So that's why I'm going to attempt this question by myself. Okay, in this question this butene-2-ene reacts with the cold dilute KMnO4 to give product X, and the same butene when reacts with hot concentrate gives product Y. We have to check the properties of these X and Y. Alright, now first of all let's react the butene with the cold dilute KMnO4. So I'm going to construct the chemical equation here. This is a simple version of the butene. When it reacts with the cold dilute KMnO4, we do the hydrolysis of this compound. According to this reaction, the hydroxyl groups will come on the carbon-carbon double bonds, or the hydroxyl functional group will come across a carbon-carbon double bond. So as a result, the product which will be obtained will have two hydroxyl groups on the previously carbon-carbon double bonds. So this is the product X. So we will label it as product X. Then the other reaction in which the same butene reacts with the hot concentrated KMnO4. So the product which is obtained is C. As a result of this reaction, you should know that there will be cleavage at this double point, and this compound will give you the, firstly it will convert into this side, or the other side will first convert into the aldehyde CH3 CHO, and this will further react. Why it will further react? Because it is in the presence of the excess, and as a result of this excess, this aldehyde will further convert into the carboxylic acid. So I can write the final product here, CH3 COOH, the ethanoic acid. This is the product obtained, and there are equal parts of this butene, so you can say that 2 times of the ethanoic acid will be obtained as a result of this reaction. Now we have to apply the options here. Option A says that only one of X and Y reacts with 2,4-dinitrophenyl hydrazine. Alright, 2,4-dinit or 2,4-DNPH can only react with the aldehyde and ketone. But in these given options, but in these given compounds X and Y, the compounds obtained as a result of the second reaction has Y. That was labeled Y. Now X and Y, only one. But here you can see that in the product of X is the alcohol. Alcohol does not react with 2,4-DNPH, so X does not react, and Y contains carboxylic acid. It also doesn't react with the 2,4-DNPH. So neither X nor Y react with the 2,4-DNPH, so A becomes incorrect. Now option B says X and Y both react with the sodium hydroxide. Now the X is alcohol, so alcohol do not react with the sodium hydroxide NaOH, but it will be called the reaction of the carboxylic acid. So yes, as a result of carboxylic acid, this product is the replacement of hydrogen or the carboxylic group with the metal. So CH3COONA will be formed. So Y does react with the sodium hydroxide. Now option D. Option D says Y reacts with the lithium aluminum hydride to give X. So Y is ethanoic acid. Ethanoic acid, when reacted with the lithium aluminum tetrahydro with this compound LiAlH4, you will get the ethanol as a result, CH3CH2OH. This is the product obtained as a result of this reaction. However, the compound X contains 2 hydroxyl groups, which is not matching with this product, so it is not the right option. The option C says that X and Y both react with sodium metal. So yeah, alcohol can also give reaction with the metal. Carboxylic acid can also give the reaction. The reaction of carboxylic acid is already shown here, and if I write this reaction of alcohol, then I can write C. I'm writing the compound X here. When it reacts with the sodium metal, it will give you ONA over here and O and A over here. So this will be the product obtained as a result of this selection. So yes, as a result of, you can see that the correct option is C. The next question is 30. This question is highlighted and this is a repeated question, but what I found that this question has not been answered previously on YouTube by anyone, so I'm going to answer this question by myself. This question says when heated with KOH dissolved in ethanol, halogen alkanes undergo elimination. What is the possible product as a result of 2-bromobutene? Now 2-bromobutene, I should write the structure of 2-bromobutene over here. This is 2-bromobutene. Now I have to draw its full displayed formula to get to the right answer. Okay, here is the full form of the displayed form of this structure. When it reacts with the KOH in the presence of the ethanol, then elimination reaction will occur. What kind of elimination will be there? There will be two eliminations. We should know that when this elimination occurs, then minus HBr will be eliminated here. But this HBr can come from two different positions. This Br will definitely be removed. However, there are two positions from where the hydrogens can be removed. Either from this carbon, on this carbon there are two hydrogen atoms. You can select any one of these two. And the other is this carbon on the left, and on this carbon there are three hydrogen atoms, so I can select this one. Okay, now as a result we get two different products. So this means that option A and B will be eliminated, because option A and B says that only one will form, so that's why these are incorrect. Now let's look at the C and D. First check D. D says the first structure will be CH3 of this side, then CH double bonded CH, and then CH3. It means that it has eliminated hydrogen from here and bromine from here. That is correct. Now the other product says that it has CH2 on one side and CH2 on the other side. That is incorrect, because either this CH3 will remain intact or this CH3 will remain intact. This CH3 will definitely remain intact. If it not, it will never be converted into CH2, because there is no hydrogen to be eliminated from this part. Only this part can eliminate the hydrogen. So this, either this is incorrect or the other one is incorrect. So it is not a right product. But option C says that CH3 CH double bond CH3 is obtained, which is the same as this, so that is correct structure. And the other one is CH2 on one side and CH2 on the other side, so that is the correct structure, which is obtained by removing this hydrogen labeled red. The red labeled hydrogen is removed. As a result of this, you are getting this product. So D is changed because of the removal of this hydrogen. So that's why the correct option becomes C. And the black labeled hydrogen will give you this product. Then question number 31, and this question is already attempted by someone else, so I'm skipping this question. Then question number 32. 4 different alcohols are treated with alkaline I2. Which is correct? Okay, here we have 2 different columns with the compounds. Okay, basically the alcohol which can give reaction with alkaline I2 should have this structure as a basic necessity for a positive test. CH3 CHOH and this further bond. If this group is present in any alcohol, then you will get the positive test with the alkaline I2. Now let's check which of these alcohols can give this product. Over here, the propane 1-ol. The structure of propane 1-ol is CCCOH. So this structure does not come in this compound, which means propane 1-ol will not give you the product. So this will become incorrect. Now we are left with options A, C and D. Okay, I'm going to construct the structure of A, C and D. A is butane 2-ol, so I'm going to construct a simple structure for butane 2-ol. This is butane 2-ol is given 2 times, so this is A and D options. Then we are also provided with the propane 2-ol. This was B option, which are be crossed. Now propane 2-ol is C, O and C. Now this is the option C. Okay, now we have to consider the products obtained as a result of the reaction with alkaline I2. When the butane 2-ol reacts with this compound, then we can see that this CH3 will be taken out for the hydroform compound or tetraidomethane. Tetraidomethane is CHI3. This is the tetraidomethane, which it is needed from one methyl group. One more thing, butane 2-ol mentioned 2 times, but the formula of the tetraidomethane over here is incorrect. This is incorrect formula of the triidomethane. So that's why this option A becomes incorrect, which means the other butane 2-ol will be considered. So in the second butane 2-ol, we see 2 products, triidomethane, that is correct, it will be produced. Still there is something more to note here. This is not the right product again, it is also incorrect. So triidomethane is CHI3. CHI3 is the right product of the triidomethane. So both D option and A option becomes incorrect. So the only option is C, but let's verify it. The C option says that when propane 2-ol reacts with the iodine, then as a result we get this as the triidomethane, and the other 2 carbons will convert into their oxidation state, which is the carboxylate ion. So carboxylate ion has 2 carbon atoms, and there are 2 carbon atoms in these two in this compound. So yeah, these 2 products will be obtained as a result of this reaction. So C is the right option. Then question number 33. The MR of compound X is 88. Compound X is heated. Under reflex with excess acidified potassium magnate to produce compound Y. Then compound Y reacts with compound X under suitable conditions to produce Z. The MR of Z is 1 cm. What is compound X? Okay, here we have two different conditions. The compound X is converted into compound Y, and this compound Y is converted into compound Z, and these are happening in these 2 different reactions. XX acidified potassium magnate, potassium dichromate, and there is another reaction which is not actually stated what kind of reaction it is, but its property is given that you are getting 172 as a product. So I will label the first reaction as the reaction number 1 and the second reaction as reaction number 2. Now I have to apply these reaction types on all these compounds mentioned in these 4 options. So I have done the working. Let's check that. Now this is the first option A. We can see that this first option A has the alcoholic group present, and this is a secondary alcohol. This is a secondary alcohol. Secondary alcohol, when react with the excess acidified potassium dichromate, which is an oxidizing agent, it will oxidize this compound into the ketone. So secondary alcohol will convert into the ketone and you get this product as a result of this reaction. Now this reaction, this compound which is obtained should react with the compound X as a result of this reaction, because it's the second statement says the compound Y react with compound X. So which means the ketone which is obtained must react with the alcohol in the original option, which we can see here is not possible. What we see here, that this is an alcohol and this is a ketone, so there is no such reaction. Alcohol reaction with the ketone is not possible, so we can write no reaction here. Then option number B. Option B contains the we can see here that option B again contains an alcoholic group here. This is the alcohol, and this carbon which is bonded with the 2 methyl groups means it is a secondary alcohol again. So secondary alcohol will after oxidation will give you ketone. So a ketone is obtained as a result of this reaction. Now this ketone should react with this original alcohol. So again we see that no such reaction is present there. In our literature especially, there is no such reaction. So this ketone, when if tried to react it with this original alcohol, there will be no product or no reaction possible. So I can write no reaction. Now the option number C. Option number C contains the alcohol over here, and again it is a secondary alcohol. This secondary alcohol, when oxidized, will give the ketone again. So this is the ketone. This ketone again does not react with the original alcohol, so no reaction is present. Now the D option. The D option contains the alcohol, but this alcohol is a primary alcohol. It is a primary alcohol. This primary alcohol, when oxidized, will give the we know it should give us the carboxylic acid. Why it should give the carboxylic acid? Because we know that in statement 1 it said excess amount of the acidified potassium dichromate. So because of the presence of the excess amount, the product will not limit itself up to the aldehyde state. Instead it will further oxidize into the carboxylic acid. So carboxylic acid is the product obtained as a result of first reaction. Now this carboxylic acid must react with the original alcoholic compound. So we do know that there is a reaction of alcohol with carboxylic acid, and that reaction is called the esterification reaction. This is the esterification in which an ester is produced. So we should know the formula of the ester which is obtained as a result of these two compounds, and the formula of the ester is this. Now this is the ester which is obtained as a result of this reaction. Moreover, we have to verify that is it the right ester, because the question told us that the MR value of this compound would be 172. So we can compute its MR value from the elements and the atoms. So there are 10 carbon atoms, 2 oxygen atoms and 20 hydrogen atoms. So when we add them together, we get 172 as a value. So yes, this is the right answer. So correct option becomes D.